there's a few of the, I just put answers to 1 and they're in italics. 1 and 4 and 5. So check those. And then I'll start going through in a couple minutes. Alright, let me start going through. So this is the stuff, some of the stuff we haven't talked about quite yet, but most of the stuff we did yesterday and like you will be responsible for on a test. So describe the data. Remember, we're looking for 4 things. What are the certain name? Form, direction, strength, context. So that's my form. It is linear. Direction is positive because we're going up. It's a strong relationship because the dots are all like really close. And then I said between calories and weight to give the context of the problem. So if I'm grading this sentence, I would be looking for 4 things. I'm not looking at grammar, spelling, sentence construction. I'm looking, is the linear, positive, strong, and then like something about the context. Number 2, find and interpret the slope. So is it negative, or is it 0.005? 0.005x and then minus like 0.75? That it is. Okay. So first of all, what does that hat mean? It's not bad. Predicted, expected, on average, approximately. Those are better, but that's not too bad. And if I asked you to write the equation and you gave me this, would you get full credit? No, because that doesn't mean anything. That's a naked equation, they would call it. So then I would have to say y equals, y is weight, and x is calories. And then interpret the slope. Find and interpret the slope. So the slope is the number in front of the x. So my slope is 0.0005. I'm going to put it over 1. Then I kind of tried to draw out my thought process in the notes. But then I saw a lot of people that didn't have this one, so maybe I didn't do a great job. But we know slope, I'm going to try again anyways. We know slope is change in y over change in x. Right? That's just like the slope. Well, in this problem, what is y? So it's the change in weight divided by the change in calories. And that is 0.005 over 1. And then my job is to describe this. So what I would say is for each additional calorie, we will gain 0.0005 pounds, or we expect to gain 0.0005 pounds. We expect it. We can't say we will. We expect to gain 0.0005 pounds. Or we predict, or on average we will. But it's very easy to confuse like which one's leading, like which one's which. So that's why I try to set it up like this. So it's always going to be like for each additional x, we expect to gain whatever y. So it's always x and then y when you write that. X is controlling it. X is what happens first. Question on interpret the slope. There were a lot of those blank when I was walking around, which is fine. Like we said yesterday, but I just want to make sure I answer any questions. Okay, finally interpret the y-intercept. So that's similar. I can tell the y-intercept from the equation. is the negative 0.75. Y-intercepts is negative 0.75. And remember, what we know about the y-intercepts is the x value is always 0. So here I would say if we eat 0 calories, calories is my x. We would weigh negative 0.75 pounds, or we would expect to weigh. We expect to weigh negative 0.75 pounds. So you'll basically float, I guess. So does that make sense in a real world situation? No, but you will still be asked to like interpret what it means.
Would it be you would lose 0.75 pounds?
No, that's not it. Please. You're thinking of slow, where it changes.
I thought that it was when I read the side. What is your weight gain?
Are you good? Okay. What? Oh, did I do it backwards?
What they're saying is it's weight gain. That's what your weight is.
Oh.
So
that's what. So we would. That's why you're saying that.
Yeah. So
Okay, my bad. So then when you said you were good, you should have said no. You're an idiot.
Because I was second guessing myself.
Yeah,
It's like how yesterday.
I get it. So we expect to lose 0.75 pounds. So does that make sense in real life? Yeah, I think that does. I thought it was like actual weight. Thank you. But Will brings up another point that we haven't talked about yet, but let's talk about it. So this data was given to us with the x values in this range between 1500 and 4500. Would it be okay for me to assume that this pattern continues and say, okay, if I'm over at like 8,000, it must be like whatever this would match up to, it must be like 2. Can I assume the pattern continues? I cannot. I don't know what happens beyond my set of data. It could do that. It could do that. It could do that. I have no idea. If you're doing this, if you're going past where we have data, you're doing what's called extrapolating. And that's bad. You can't assume the pattern continues. It could be like at a certain number of calories, like something changes. I don't think that's actually true in this case, but you just want to be careful. I don't know if that's what you're bringing up or not, but that's what you're thinking of.
I don't really know how I brought that up in the first place.
Alright, questions on 1, 2, or 3? Alright, which variable is x? So the x variable is one of the x-axis, which is calories. Two other names for the x point. So independent explanatory. You can say input, which variable is y is the weight. Dependent response, you can say output. Find the correlation. So this is, we haven't really done this yet. But I did give you enough for the chart, did give you enough information. What variable represents correlation? R. Well, that's R squared, which we haven't talked about what it means yet. But how do I go from R squared to R? Square root it. So the square root of 0.94, I don't know what that is. Right, so like 0.97. So that's your correlation, 0.97. The R squared is literally just taking the correlation and squaring it. We will talk about what it means, we haven't yet. But for now, the R is 0.97. If I measured the weight in ounces instead of pounds, what would R be? 0.97. If I measured it in milliliters, so it doesn't matter what I measured it. Like the idea is, if you eat more food, we expect you to gain more weight. That's always true. It doesn't matter what I measured it, that relationship exists. So it's just going to stay. If I flip-flop the variables on the axis, what would R be? Point ends up. It would be the exact same. Doesn't make any difference. It would still be point ends up. The graph would kind of change. It would flip, so the line y equals x is on the lines would change, but the correlation would not. Suppose I put another point at 6,000, comma 0.4. So I was trying to give you an outlier. So 6,000, probably here somewhere, and then 0.4. So right around there. And I want to know what's going to happen to R, what's going to happen to the slope, and what's going to happen to the y-intercept. So R represents the strength of the relationship. How tightly together are these points? Closer to 1 means stronger or weaker. Stronger. Closer to negative 1 means stronger or weaker. Stronger. So closer to what means weaker? 0. Coming to 0. So this is making it stronger or weaker? It's weaker because it's very far away from the rest of the points. So it's going to make the strength weaker. Well, the strength was a positive 0.97. So is it going to increase or decrease? It's going to decrease. R is going to decrease. R goes down. What about slope and y-intercept? So remember, if I give you an outlier in the x direction, so it's like way out to the side, it's the worst, least creative name ever. It's actually called an influential point. It influences things. And that would take this line, and would I tilt my arm like up or down? So it's going to make it like more like that, right? I don't know if it'll go that far, but it'll tilt it down toward that point. So then what happened to the slope? Increase or decrease? I was here, and then I got flat. So that's a decrease, right? And then the y-intercept's like my elbow. Well, if my slope decreases, doesn't the y-intercept have to increase? Those are kind of opposites. Like if the line gets steeper, the y-intercept goes lower. If the line gets flatter, the y-intercept goes higher. So that'd be increase. Questions on the world? Those are all really good questions. Really common ones you'll see on review, on a quiz, on test, on AP test, whatever. Anything I can clarify and go through again? Did I get to someone? 8 is R would still be the same. And 9 is what we were doing. Pretty good. Alright, you got a lab in front of you, so it's kind of just more practice of the same idea. But it's more fun than just throwing numbers up on the board. So get a partner. You have a tennis ball. You work in groups of 1, 2, 3. 4 is probably a little much. And this is what you're doing. So follow these. You have a tennis ball, get a partner, follow these instructions. If I can help, let me know, otherwise get to it. You can go in the hallway. But the other way would be like impossible. How you do that? How would you want it to? But if you want to change it, hey, the times that are on there, listen up, because I've changed it a little bit. So you know on the top it says like 10 seconds, 20 seconds, 30 seconds, 40 seconds. Change it so it goes up by 5 instead of goes up by 10. It'll save like a ton of time. So make it go 10, 15, 20, 25, 30, 35, 40, etc. Yeah, got that. Change the time to go up by 5 instead of 10.
I don't know the time. It's not lasting. No, I think I bounced. I think I bounced it. Yeah. Okay. I don't know.
Oh, throw. Just go. Yeah. Just go. Wait. So like this. Oh, it's probably like this.
It was exactly two. Yeah, I'm not trying to go fast. Yeah, I would. Yeah, I didn't really say that. Oh, this is gonna take so long. Can we switch it? Wow, that's crazy.
Oh.
Ouch. Yeah. That's pretty consistent. Yeah. Okay. Yeah. Yep. Is every time 5 seconds. Every time the timer. Yeah, so that we don't have to see 1 second on it.